Welcome to the SimuGator LSAT lesson for the June 2007 Logic Games. For more free information about preparing for the LSAT and applying to law school, visit simugator.com/blog. Understanding logic game strategy. This involves three things. Read, understand, and summarize the rules. Create a diagram or a series of diagrams based on those rules, and then use the diagram to help find the right answer. The LSAC is very strict about protecting their copyrights, and so this lesson will not produce the actual test questions. We're only going to go over strategy and answers. But you can, however, download the June 2007 LSAT for free at the following address. So read the problem to yourself right now. This is how I would summarize the rules. We have 5 variables for 5 positions, 0, 1, 2, 3, and 4. On test day, I wouldn't write out variables or positions. The value of slot 2 must be twice the value of slot 1. And finally, the value of slot 3 must be less than the value of slot 5. So now I'm going to draw out 5 slots just so I can visually see how things are going to work. And I think that Rule 2 is a very powerful rule. And when I say powerful, I mean that it'll probably affect the positions of most of the variables in this problem. So where they can go and where they can't go. So I'm going to try to make some deductions. And I want to figure out what numbers are mathematically capable of going in slot 1 or slot 2. So I'm going to multiply each number by 2 to see what happens. So 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and 4 times 2 is 8. This tells me a lot. It tells me that 0 can't go in slot 1, because if it went there, slot 2 would also have to be 0. However, we only have one 0. Not going to work. For the same reasons, 0 can't go in slot 2. 1 cannot go in slot 2, because if it went there, slot 1 would have to be 0.5. It's not an option. 3 cannot go into slot 1, because if it went there, slot 2 would have to be 6. Again, not an option. 3 can't go in slot 2. If it went there, slot 1 would have to be 1.5. Not an option. So basically odd numbers can't go in slot 2 is the drift I'm getting. So 4 can't go in slot 1 because if it went there, slot 2 would have to be 8. Again, not an option. So now this is a big theme in logic games, which is focusing on where things can't go to tell you where things can go. Big theme. So this reveals that we have only 2 options for slots 1 and 2. Slot 1 can be 1, making slot 2, 2. Sorry if that's confusing. And slot 2 can be 2, making slot 2, 4. Now we have a huge deduction here. We can start our diagramming. Now, when you have only a few possibilities like this, basically you just want to make 2 separate diagrams. It's going to help you keep things separate and proceed easily. So that's exactly what I did. On the left side I have master diagram 1, and on the right side I have master diagram 2. Now I'm going to see what we can do with Rule 3. And again, I'm going to focus on where things cannot go. We are told that the value of slot 3 must be less than the value of slot 5. For our purposes, for logic games, this essentially means this. Slot 3 cannot contain the highest remaining number, which is 4 in diagram 1 or 3 in diagram 2, and slot 5 cannot contain the lowest remaining number, which is 0 in both diagrams. Because if it weren't this case, any arrangement would violate Rule 3. So whenever you have a less than or greater than rule in any logic games, use this little trick, and it's going to help you a lot. It's going to lead to some breakthroughs in deductions. So this is how that rule works on our diagram. Basically, below the slots, we're going to put where things can't go, just to help us visualize it. So we've implemented the negative deductions that Rule 3 gave us. Now I'm going to determine where things can go. So first I focused on where things can't go. Now I'm going to focus on where things can go. And I'm going to add them to the diagram. So this is a complete set of diagrams. I basically just made a little slash where they, for multiple numbers, if multiple numbers can go in that slot. Now, some people have a great mental ability and probably wouldn't have taken it this far. So if you can imagine in your mind the different placements and combinations and how things would work without writing it out, that's very good for you. A lot of logic games involves figuring out a method that works well for you. But we're going to write them all out. Some people might have actually did just that, write all 6 solutions out. Every possibility, they would just bang them out real quick. Find out what works for you. This is how I'm going to do it. And note that all of this diagram would be done quickly in under 4 minutes, with 4 minutes remaining to solve questions. The good news is that once you have a good diagram, you've completed 90% of the required effort, and solving the questions are very easy. So if you haven't done the problems yet, pause this video, use the diagrams to solve the questions, and when you're ready, click play, and we're going to review them. So question 1. We're told that 1 must go in slot 5. Look at the diagrams up top. The only way that 1 can go in slot 5 if we're in master diagram 2. So I'm going to draw out the diagram that we have up top and put 1 in slot 5. Now we know that 3 cannot go in slot 3, and as such, based on what we have here, the only place it can go is in slot 4. Put it there. Fill the remaining number into slot 3, and that remaining number is 0. So the diagram looks like this. So we know when 1 is in slot 5, the diagram must in fact look like this. This is the only solution. So all you have to do is look at the answer choices, cross out the ones that don't match up to this diagram. And when you do that, you'll find out that answer choice A is the correct answer. Okay, question 2. You'll be surprised to find out that the diagram for number 1 actually produced the following solution, and you can use your previous work to solve future questions. This is another big theme in logic games. So this is a must-be-true question, which means that all of the wrong answers could be false, which is the converse. Must, could, true, false. Now this question's easy because we're going to go right to the answer choices based on the diagrams that we have. So between the diagrams from question 1 and our master diagrams, we can just go right to the answer choices, like I already said. Basically, you're using the diagrams as a counterexample to each answer choice to reveal whether they could be false. So literally just go through the answer choices, find a counterexample in the questions. That means they could be false. Eliminating all things you can contradict, you'll find that answer choice C is correct. It's the only thing that is true in all of our diagrams that we have. Question 3 asks, what happens when the third digit is not 0? So let's find out by doing just that, not putting 0 in slot 3. These are the resulting possibilities. So I'm going to put, in the first master diagram, I'm going to put 3 into slot 3, and then comply with the rules, and I get 1, 2, 3, 0, 4. And in master diagram 2, I'm going to put 1 into slot 3 instead of 0. Comply with the rules, and I will get 2, 4, 1, 0, 3. Now, I'm going to go through each answer choice and do the exact same process of elimination that I did in question 2, comparing each answer choice with the 2 diagrams where 0 is not in the third slot. The answer choice must be true in both of these diagrams. Very easy. Answer choice C is the only one that works and is thus the correct answer. Question 4 asks, what combinations of the third and fourth digits could be an acceptable combination? Again, look at your previous diagrams from question 3. They immediately show that C and D would not work. Because that they would work. So C and D would work. Thus, they're not the correct answer because the problem asked for except. So immediately we can eliminate C and D without even doing much work. When I say use your previous work, I mean that on test day in your test booklet, you're going to write out each mini diagram and you're not going to erase it. So you're going to have a set of diagrams already done. And you'll notice that the work from question 2 eliminates choice B, because it does work. So this leaves us with A or E. Now I personally would just glance at our master diagrams and try to mentally see what happens. So for A to work, we would have to be in diagram 2 up top, which would give us 2, 4, 0, 1, 3, which is a very acceptable combination because it complies with every rule. This means that A works and is thus incorrect, because except. For E to work, we would have to be in diagram 1, and we would have 1, 2, 3, 4, 3 or 4. And as you can see, there is a conflict because choice E would require the repeating of numbers. It does not work and is thus the right answer. So answer choice E is correct. Question 5 asks about the spaces in between each digit. Note that at most means maximum. So at most 2 would mean less than 3. However you want to think about it and understand it is fine. Again, our work from questions 3 and 4 will help us in addition to our master diagrams. So there's our master diagrams, there's our previous work. Master diagram 1 disproves A. So just look at A, compare it to master diagram 1, and you'll see why. Master diagram 1 also disproves B, because there are no digits between 1 and 2, but it clearly works. Master diagram also disproves C, because it says that there can be 3 digits between 1 and 3 if the 3 goes in slot 5. That's perfectly acceptable. Master diagram 2 disproves D, because master diagram 2 shows that there can be 3 digits between 2 and 3 if 3 goes into slot 5. So it's not at most 2. So thus answer choice E is the correct answer. Although there are no digits between the 2 and the 4 in master diagram 2, it does show that there are no more than 2 spaces maximum. So maximum, not minimum, is the focus here. So answer choice E is correct. Now we have some concluding thoughts here. Hopefully this tutorial has served as a thorough explanation to June 2007 Logic Game number 1. But more importantly, I wanted to have given you a visual insight into how to approach logic games in general. So focusing on where things can't go as much as where they can go will lead to great breakthroughs and inferences that you might otherwise miss. And it'll help you solve the questions. That's something you can apply to any logic game, not just this logic game. Use the master diagram to solve the problem, and if you can't, make a mini diagram based on the master diagram specific to that question, and this will show you how things play out. So never erase your previous work. You always want to leave your previous work there, and just glance at it if possible. So when you start a question, glance at your previous work, see if it's going to help you. It's something that will take 1 second, but if it can in fact be helpful, it'll save you a lot of time. Some students do not appreciate the helpfulness of this tip because they may feel like they're cheating or they're not really learning the LSAT. But you have to remember that your previous work is just one full solution for the problem at hand. It won't always solve the next problems, but it still cannot hurt you to consider it. Why redo diagrams if you have a great solution in front of you? So we hope that you have enjoyed this video lesson. We're going to make more for logic games. We're going to make as much as possible, also for logical reasoning and reading comprehension. We hope you've enjoyed, and if you have liked this video, hit subscribe, maybe check out our blog, and good luck to you in all of your LSAT preparation.